Hold steering wheel. GPS signal lost.
Tower, gunship 12 ready for departure.
Copy that. 12.
Repeat, Tower. Could not understand you.
Sir, the TT&C receiver appears to be jammed. I think we've lost control of the satellite.
Radio frequency systems are pervasive. We rely on them for entertainment, communications, navigation, and sensing. When a receiver experiences interference due to nearby transmitters, we have radio frequency interference, or RFI. Interference problems cost corporations millions of dollars with last-minute design changes and delayed product releases. Interference from military systems can result in degraded capabilities, and in extreme cases, loss of the vehicle and loss of life. What makes RFI challenging is that most interference problems are not obvious. It is typically the out-of-band or unintended performance of the transmitters and receivers that are the source of the interference. For example, transmitters generate both the desired fundamental signal but also out-of-band signals such as harmonics, spurious emissions, and broadband noise. Similarly, receivers have their intended response but also spurious responses and a non-ideal selectivity profile. In an attempt to avoid finding RFI problems late in the design cycle, companies try to simulate the potential for RFI. These simulations require broadband data for all of the components in the RF architecture. For many of the components, such as filters, amplifiers, and cables, one can typically obtain the S parameters from the vendor or perform a quick measurement with a VNA. However, RF vendors do not provide broadband data for their transmitters and receivers. Without measured broadband data, analysts resort to specification sheets for commercial systems and DD 1494s for military systems. Unfortunately, neither specification sheets nor DD 1494s provide the level of fidelity required for accurate RFI simulations. This results in predicting many interference problems that do not exist, and completely missing real interference problems. And both outcomes cost companies and organizations time and money. EMA has developed the Automated Radio Measurement System, known as ARMS, to provide analysts with the high-fidelity data that is needed for accurate RFI simulations. Key ARMS features include extremely high dynamic range for transmitter measurements, broadband susceptibility measurements for receivers, and automation to minimize human interaction. Using data collected with ARMS, RFI problems are found early in the design cycle, such that the most optimal solutions can be deployed to resolve the interference. Contact EMA to learn how ARMS can be used to avoid costly RFI problems.